So for this, we'll sort of combine both definitions. With the real-time semantic web meaning fast, event-driven RDF data flow. I'm going to talk about sort of how fast is fast enough. When you have a human in the loop, there are some reasonably well-defined thresholds for real time in terms of the notion of simultaneity. Simultaneity means that you can't notice a delay. It's used for in an intramodal sense, in that if you hear two sounds, if they're close enough in time, say for audition, it's a very, very small time frame, like 2 milliseconds. The two sounds are perceived within 2 milliseconds of each other. They're perceived as the same sound. Otherwise, they're perceived as separate sounds or consecutive sounds. In the case of intermodal stimuli, like somebody snapping their fingers, you see the motion of my fingers moving, you hear the sound, and if you're close enough to me, you'll perceive that as a single event. If there's some lag on this video that's greater than about maybe 50 milliseconds or so, then that will seem not natural. So that's sort of the extreme limit of what it's useful to talk about in terms of real time when it's a person that's receiving the information. So how close to those limits can we get? Actually, we can get very close. All these figures are from yesterday, just some simple experiments I did. Convert a tweet, map a tweet into RDF. That takes around 1 millisecond for each tweet. Ingest that tweet into an Allegro graph triple store. It takes about 4 milliseconds if you batch the commits. Computing a Sparkle query results that yields about 300 results, including intermediate results, and three joins. Took about 5 milliseconds for Twitter data in the Allegro graph. Sending and receiving a FIPA message, I'll tell you what FIPA is in a moment. Takes about 1 millisecond if you exclude the transport time. So most of those are well below the real-time limit I just defined. Meanwhile, though, just sending a message between here and a remote server takes a significant amount of time. If you ping a server in California from here, it takes around 85 seconds, depending on many things, 65 milliseconds. The least that it could possibly take if you're sending light through a vacuum would be 28 milliseconds, which is still pretty significant. And if you're talking to a server on the other side of the world, it would take upwards of 140 milliseconds. So well above those simultaneity thresholds. So really, the bottleneck here is the communication. It's not the semantic web tools in the middle. There may be certain reasoners that can't perform at these levels, but what I'm saying is that semantic web tools are ready for these sorts of very demanding applications. So what about throughput? How much data can you push through a connection? Well, you can, if you were sending data from San Francisco to here, you can get most of the Twitter firos over a single connection. You can get an equivalent volume of RDF data, around 20,000 triples per second in an experiment I did. And existing triple stores can actually ingest that data. It can keep up with that pace. Actually, the graph can ingest many more triples than that per second. So you can not only stream the data, you can put the data into a triple store, and you can execute Sparkle queries over it all in truly real time. it matters a little bit what protocol you use. Which with HTTP, you get a certain throughput, which is what I'm referring to here. With UDP, you get slightly higher throughput, but there are some constraints because messages don't, or datagrams don't arrive in order. They can be lost without you knowing about it, and so on. But for certain applications, that might give you like a 50% performance boost to use UDP. But anyway, the performance numbers are pretty close. So again, the point is that that the technical limits and human limits are pretty similar, and we have software that can operate at those levels. But we need an architecture that supports peer-to-peer communication to cut down on network latency, and that can adapt semantic tools to streams and to conversational interaction. So from here on out, I'm going to talk about a few different tools. This is TWed logic. It's a tool that maps tweets into RDF and facilitates interlinking for data, any data that might be contained in the tweet with the semantic web. And this is on the Twitter streaming API. Translates the JSON of the tweets into RDF, looks for any embedded RDF statements or anything you can make into a statement. At one point there was going to be a feature called Twitter annotations, which would have provided a lot more rich data. Hasn't happened yet. Unclear whether it will happen, but probably similar things will happen either in Twitter or in other services. Streams that data into a database with an RDF agents connector and so on. So just an example of what a tweet looks like in RDF here. At the top, the tweet is being modeled as a shup types microblog post, has a timestamp. There's location information, and the content of the tweet says who it was written by. It has a couple of topics, which are just hashtags in this case. And then this particular tweet contains some embedded information. So somebody has said something in a nano format or a special format that is seen as having some semantic meaning, and that's linked here.
So is that the actual, where you've got the content, the Karate Kids, karate versus Kung Fu, is that the actual tweet?
Yeah, that's the one of the 14 character text of the tweet. And the rest is metadata about the place. And then this is the embedded information saying that the Karate Kid is a movie. It has this page on Rotten Tomatoes. It's the same as the Wikipedia resource for the Karate Kid. And I've described a few simple ways of establishing those mappings. Again, it could be applied in other domains apart from Twitter.
So that information below is being generated from the actual content that says the Karate Kids, right? Or is that?
It could be if there are a format for you to say these things, but in 140 characters you would be able to. In this case, there's supposed to be an annotation attached to the tweet, and that annotation has a topic, and the topic is the movie, the topic has a title, the topic.
Oh, that's what the Soch topic is right there on the top?
No, these are, those are tags that are tweets. Actually, wait. Yes, actually, that's, those are the two movies that are described.
how is that instantiated inside of the tweet itself, or that other data outside of the tweet? Or how does it know that Karate Kid was mentioned in this? Did they do some language analytic or something like that to recognize that?
No, it was supposed to be a JSON format.
Oh, okay.
So we're,
So if I switch to another presentation, I can show you what that will or would have looked like.
so it's, yeah, so we're not seeing what the actual tweet was. That's not contained here. It's derived from whatever the actual tweet was, that the content stripped of all the special tagging is the Karate Kids, karate versus kung fu, and all this other information as well. It's derived from the markup.
Yeah.
Oh, I see.
You wanna-
Okay, good. Because I looked at the content and it's like, okay, there's nothing in there that would point to a movie or anything like that unless there's some kind of text comparison or.
Okay, so here is the JSON that's attached up. There's a couple of movies, they have titles, they have URLs, they have text, and then an additional property I suggested was the same as, which is a way just to link to a semantic web resource.
Okay, so this is using the as yet to be created annotation.
Yeah,
format.
exactly.
Okay.
That doesn't exist.
Okay.
But you know, it's similar to other things that do exist, like microdata. And I think that inevitably those sorts of formats will spill over into the real-time domain as well, whether it's through Twitter annotations or something else. Okay, so some use cases for that. You know, what sort of subscriptions could you define if you have this sort of information? Give me tweets about places in developing countries. So the idea is that the information contained in the tweet, because it's represented in RDF, can easily be superposed on static semantic web data, like the GNames data set, Wikipedia, link data. So this triple pattern draws in information in the tweet. As a post, it has it embeds some knowledge. It's about some place, and the knowledge about the place that's embedded in the tweet is that it's a feature, and it's the same as something that's described in GNames, and the GNames has some metadata that lets you further constrain what sort of places you're interested in terms of topics of tweets. Another example, using linked movie data, giving English language movies starring Chinese actors. There's a microblog post, again, it has some information. It's about a movie. The movie is the same as a movie that's described in Wikipedia and the linked movie database. Has a particular language. It stars a certain actor. The actor belongs to a certain class, Chinese actors. One more of these tweets about songs by artists my friends like. This one uses both data and music brains data along with the data of the tweet. There's a tweet, it contains some information. It's about a song. The information we have is that it's a song. It's the same as something that's described in music brains, and there's some more constraints for that combine the music brains information with both information about your friends. So the next tool, TWed is a tool for producing data and for matching up data. RDF Agency is a tool for sharing data. So the specifications extends the FIPA agent communication standards FIPA is a set of standards dating back from the 90s and early 2000s that just gives a sort of a standard set of communication protocols, defines how agents exchange messages, how they indicate the content of the message, and so on. So I've combined that protocol with semantic web as the content language and name graphs and the provenance mechanism that I mentioned of A says that B says C. Right now it has two interaction protocols, the query and publish subscribe. Here's what they look like. Here's a query, which you saw in the examples. There's an information consumer is posing a query to a provider. The provider can decide what to do with that request. Refuse to answer it, I'm not interested in answering. You can agree to answer and get back with the result. The subscription protocol is only slightly different from that. Consumer subscribes to a certain topic, says, this is what I'm interested in. If you get any information about this topic, let me know. The provider can refuse that subscription or agree to honor that subscription, and then anytime some information comes in, a tweet about the title of this world, the provider will send that information back to the consumer. They consider to cancel their subscription. So here's what a message looks like. The RDF payload is down there. There's a microblog post that's modeled in RDF. Has a topic, has some content, a timestamp, and this is the information that describes the conversation. So it's a publish subscribe conversation. It has a certain ID, so agents can have multiple conversations at the same time. It has a particular RDF language, in this case straight. And up the top you see the sender and receiver of the message. So this gives an implementation, a way of routing messages to the right parties and carrying RDF information with provenance in these messages. So some other useful tools that I didn't write. CSparkle is a Sparkle implementation and a language, a Sparkle extension for continuous queries. There's a CSparkle plugin for RDF agents now. And continuous query is where you submit the query and get back results as they realize, like in the subscription examples that I showed. Sparkle push is a way of creating RSS feeds out of Sparkle results. Again, it's a subscription mechanism that's based on HTTP post. It's good for what it does. SMOB is the semantic microblogging framework. And it also includes something called sharing spaces, which is useful for defining your presence on the web. Like say you want only your friends, when you go onto Skype, you want only your friends to know you're there. You don't want your business contacts to know you're there. You can specify those sorts of things in Sparkle. Then there are a bunch of mobile semantic web libraries. Some of them allow you to consume linked data on your phone. Others allow you to publish data. A few vocabularies that are used in the tools I mentioned. Semantic web publishing vocabulary is used by RDF agents to define the name graph provenance of information, capturing the provenance trail. The Shuck ontology is used for modeling blog posts, microblog posts. That's used in RDF agents. So is FOAF, which is used for modeling people. Probably most of us are familiar with those. The online presence ontology is used in sharing spaces that I just mentioned. And some more tools. So Sparkle OSC is a tool for taking continuous sparkle queries and translating the results into multimedia messages, into OSC messages that can control multimedia devices, cameras, speakers, whatever. It's sort of an emerging standard for real-time communication among all kinds of devices.
So, go back to that, please. How would that be? Give an example of what that would be used for.
Say you just want a notification of a certain kind. Say you want to be notified when tweets about the Devil's World come in. You can have set up a ground notification or something. But say you wanted some other device to react to that information. Yeah, I don't know. I mean, you could,
What I thought you might say is, so there's these guys who do sound interpretations of patterns, like stock market, that sort of thing. And I thought you might use, that to me seems like the kind of thing that you would control with this.
yeah, so I haven't looked at those.
I don't think they do it this way. I'm not saying that, but I'm saying that this would be, something like this would allow you, anybody to create that sort of thing fairly quickly, it would seem. When you're watching, yeah.
That's a good suggestion, so.
It's like you could be watching tweets that have, I mean, even regular tweets, that are marked up the way we currently mark them up with $sign Microsoft or whatever, and you could be watching for interesting information about those and then controlling some, like MIDI. I assume, does this talk to MIDI or is this?
OSC is kind of an alternative to MIDI.
Oh, okay, so it's like an open.
So yeah, you could use it for some of the same things as MIDI is used for, but it's not only used for sound. So you could use it to control lights on a mono, whatever you can think of. It's just a really simple format where you have a sort of a URL that identifies the recipient and then just a tuple of strings. Turn this light in that direction. Make a beep. Tell this robot to turn left or whatever.
Make this video work.
Yeah. I don't know why this is suddenly not working.
So can you talk about, whoops, there you go. Just happened. So I realize that, well, I don't want to interrupt your flow, but I did have a question. So this is presuming a particular model of like agent messages that are very rich in semantic markup relative to what we currently have in Twitter, in the 140 characters that we currently have. And we don't have that right now. We don't have Twitter annotations.
Right.
But we do have a lot of sort of ad hoc techniques for doing sort of semantic markup of tweets. I'm wondering what and it also seems from what you've said, you've presented some examples of querying, if assuming that information is being gathered querying to do interesting things based on what's the triples that are being accumulated. I'm wondering what is doable. It seems like part of this is doable given today's way of marking up. I'm wondering, are you going to speak to that, or can you talk to that?
Yeah, so with TWed, I sort of started with the idea of nano formats, which are whatever format you can think of to express something with a certain structure. Twitter data was an early example of that, a format for saying things like, I am in this location, I like this thing, I know this person, and that can be translated very easily into RDF descriptions. I introduced a format that was fairly compact. You just add a couple of parentheses after a hashtag, Semtech, a conference in parentheses. That gives you a little bit of markup that says that Semtech is a conference, and so on. So whether any of those formats will ever see much uptake is sort of open. Probably in specific areas they might be able to. When Twitter annotations came along, that became a lot less attractive because it sort of became obvious that some of these services are going to start providing better data, really actually structured data, and that we can work with, do more interesting things with than we can with very loosely structured text and NLP and just limited formats which people may not use or will tend to use sloppily and so on. But yeah, that's possible. If people were willing to format their tweets in a certain way, we could certainly extract some semantics.
Well, yeah. So there's formatting tweets in the special ways, and then there's the inferring what people are talking about using the minimal formatting that we currently use. Like the hash Justin Bieber, okay, and I've got a query set up to be alerted when my well, okay, hash Tom Brady, okay. But so my point is that some of the use cases you gave earlier of watching for tweets about bands my friends are interested in, well, you can describe that, the watch for tweets about friends.
Yeah, I do that with hashtags and URLs.
Right.
So you don't even have to parse those anymore. Twitter gives you a list of all the hashtags, it parses them for you. And those are translated into hashtag resources, which are, arguably not the same as those proper semantic web resources, but can be used in some of the same ways. You have a hashtag TWC RPI. There may be other uses for that hashtag that indicate something other than the Titleist world, but depending on your application, it may not matter if that level of ambiguity is acceptable. So yeah, you can. I'll skip straight to example here. Here's a Twitter widget that's actually based on Sparkle. So this isn't going directly to Twitter. This is going to a triple store. And querying for, actually show the Sparkle query here. I need to dig around for it, but so there's a Sparkle query that constrains what sort of tweets you'd like to see. In this case, just something very simple. Show me all the recent tweets about ISO 2010. That's all the tweets that contain this hashtag. But that's actually not the hashtag ISWIC 2010. There's a little bit of logic in there that says that ISWIC is the same as ISWIC 2010. It's the same as ISWIC 10. See if this still works. Showing tweets about ISWIC authors. So there's Semantic Web dog food data about all the authors of papers who published at ISWIC, and that's in the drugstore. I'm not sure if it's getting it or not. I'm not sure if Sandra wrote a paper and this person wrote a paper.
So that's a good example of the kind of thing I was thinking of, where it's kind of this, you're doing something really interesting, but you're not constrained by, you don't have to wait around till annotations start getting used. You're doing something pretty useful, and which is better than creating queries that are hash ISWIC, hash ISWIC 2010, hash, all the different combinations.
Yeah, and so the more, so the richer your background data becomes, the dog food data is a pretty good example. There's a certain event, and that event is described in RDF, and doesn't link out into the rest of linked data very much in this case, but could. And if it did, you could search for tweets by all of the authors from Romania, or whatever you can think of, whatever you can express in this properly.
I got you way off track. Sorry about that.
No, that's okay. This is supposed to be
Actually, I mean,
track.
we're way off track anyway. You said that there's some logic in there to tie together hashtags ISWIC, ISWIC 2010, ISWIC 10. How is that managed? Because it seems like, I mean, that's just a big problem waiting to happen when, the following year that's no longer true.
Yeah.
Right? And without deep buy-in from Twitter or whoever to get really high quality annotations, it seems like you're trying to, bandage over this huge problem with things that are going to result in bad data.
Well, yeah, that's a semantic web problem. How do you integrate data sources? In the case of Twitter, the Twitter Places integrates with Foursquare.
Well, just for the
Which,
semantic
if
web one, how do you
Foursquare were
deal with
willing to set up, same as links from its resources into geonames, then you would have that linkage. In this case, some links have been manually added for the sake of a demo. But
And if that demo was untouched until next year,
you
Does
can
bad
already
data
see the effect.
pop out?
It's 2011 now, and that's no longer valid. ISWIC 2010 is not necessarily the same thing as ISWIC.
and
So that's not so much
is there an answer to that without getting big serious buy-in from Twitter?
Well, in this case, hashtags are sort of a poor substitute for semantic web resources. If we had
Well,
better
but
linkage.
even in this very scoped community, it seems there's a problem, right? Every year we know what the hashtags are for ISWIC, but this still seems like a problem because people use ISWIC instead of ISWIC 2010 or 2011, right?
Yep. And that's a very good argument for better, more structured data coming out of these services. So instead of a hashtag that somebody's typed in, maybe in your Twitter app, you type in ISWIC and you get a little drop down. Did you mean ISWIC conference? If so, then it adds an annotation that says this thing is a conference. This thing is the same as an event that has been described in some other
Yes,
service.
if anyone's looking for a get-rich-quick scheme, I think a hashtag management site that can generate as a Twitter plugin has some real opportunity, and then something like that can do. So you often see a hashtag that's some conference, and you click on it, and all you see is people at it. You'd love something that would let you say, give me all the, so you could get the organizer of an event to put that in. And then, I would handle Greg's problem simply by using temporal, show the most recent ones first. So ISWIC is always ISWIC. If someone's logging ISWIC recently, just make that the most recent one they see and they'll go back. But if right now I logged something about ISWIC 2009, you should assume it's ISWIC you know, it just seems to me it would be, I keep wishing I had such a thing, right? And then you could imagine event organizers being able to say, here are the set of, here's the homepage, here are the Twitter tags being used, and you could have a new one in whatever form. And this service would find it, use it, bring them together. It just seems like a natural. I've been looking for such a thing, and I can't seem to find anyone who's played with one.
Yeah,
It just seems like a big win.
we certainly need better user interfaces for just
But
for tying
almost
anything.
anything that has tags, right? You can't tell people what to use, so you can't get a formal system out of tags. But it seems like you could take the tags, use them. In this case, it's pretty simple. Just ask people to give people a reward if they take the tag to a place. So I'm an event organizer, and I say I want people to tweet about it. I want that to come to my site. I'm motivated to tell you what tags go with my site. And by the way, then people in Twitter will be able to click on that tag, see my site as a pop-up or something. You know, I think you'd have one of these ecosystems which would be self-enforcing, and then you figure out how to sell things. Trending things are, so the top ads in the trending side cost $120,000 an ad, so there's clearly money in this space. Just worth thinking about. I'm happy to be on your advisory board if you start with something. Well, even Bottlenose isn't doing it. So Bottlenose is a new Twitter thing. Nova's doing it, has all sorts of cool stuff. And I'm like, Nova, where's the hashtag stuff? He's like, well, you have to get people to do it. I'm like, well, motivate them.
If you know, so,
Now we're way off the top.
well, I know, yeah, but this is kind of interesting.
Get it
Because,
to the end anyway.
you know, if you had the URL for, if you had the URL for ISWIC, the conference, and you pasted the full URL into Twitter, and you have as a sort of a super shortener app, Jim's app, what it would do is it would say, oh, I know what the standard shortening is of this ISWIC because the conference organizers organize. And by the way, I've got the 3 hashtags that they also organize. So you put in the URL, and you've got a shortened URL and 3 tags to ISWIC, all just put in.
Either that, or it does a little bit of any of the extraction on your text way type thing.
So, just I got to contact my copy.
Yeah, I'm not totally sure that text extraction would do it. I think you need, because again, these things won't be unique.
This is a registry.
So when the international, I forgot what there's another ISWIC. It's wearable computing,
yeah.
International Symposium on Wearable Computing, right? And they're going to blog ISWIC too. So, but again, if you have this manager, they would see that. They could decide to change it. We could decide. But also, I'm at an event, and I always end up, popping up 3 or 4 windows so I can follow the tweet stream from that event. And even when the organizers say, please blog this as ISWIC 2011, you still have people doing all sorts
It's all a matter of social convention, and, that's kind of what they represent at the end. Things like what the trend and other things try to measure that.
Well, that's, yeah.
And so you try to put authoritative source on something that this collective group trying to build a consensus around is not difficult, but it's difficult with the record type system. You need a more social mechanism system to be able to measure and control that. So something where you can measure or see what the consensus currently is and the explanations for that, and how it's ever changing and growing.
So
25 pages.
So Bitly has sort of been able to do, so one of the interesting things about Bitly, sorry to get you off track, but this is that's part of what we're supposed to be doing with these things, okay, is, so Bitly becomes a way to, personally, to snoop on the popularity of stuff that you've done. If you take the time to register your Bitly and have that version of it be what you're shortening with, and I'm sure the other ones work this way also, but yay, Libya, rock on. It's, you can follow, they aren't just going into the bit bucket, you can follow.
Yeah, it's a good way to see how many clicks you got.
Exactly, you can see what the trackability is, I can find out, I tweeted on that, and I had, well, 250 people. Now, they may have been through RTs or you know, some may have copied it in a blog post, but there was 250 clicks based on this that I did, instead of just simply putting it in. Now
Or you get
that's-
5 clicks and then you know, my followers are not interested in this sort of information.
That's right. Well, all 5 click them.
All right, so back to the slideshow. That's Sparkle OC. Sesame tools, let's see, I mentioned that 2 or 3 more tools here. It's just a collection of tools I use with the Sesame Open RDF framework. Some of them are especially good for creating real-time filters and working with transactions and so on. So that's there. Interested in. Sesame real-time. Ripple is a programming language I wrote that is it's an RDF path language, and it's also expressed in RDF. And it's the computational model of the language is based on push-based data flow, which makes it good for rapidly changing data. Tinkerbot is a collection of graph database tools, some of which I've written. Most of the tools I've written have to do with semantic web crossover in some way. There's a tool that makes any of the number of graph database implementations into high-performance RDF triple stores. You can execute Sparkle queries over the Neo4j or the OrientDB database, query them as if they're RDF triple stores, put triples in, get triples back up. There are mapping tools for translating between RDF and a few different graph data models, and it allows you to apply graph algorithms to RDF data sets, of which there are many other ways, but this is one.
So I've been following, somewhat for a couple of years, what Marco Rodriguez and you and you guys have been doing. Can you talk about why this is interesting? I mean, why the crossover into graph databases is interesting?
Well, it's interesting in part because they're, these graph databases, are out there, first of all, and have certain properties, but do not need, you don't need, this, the first rule on the list here, you don't need to write a special, you don't need to create an RDF triple store from the bottom up. Not only that, but if you say want to use Neo4j as a triple store, you don't have to write a special RDF adapter for Neo4j, which is something that was done before. If you want to use OrientDB as a triple store, because you want to use the facilities that OrientDB provides, or you don't need to write a specific triple store for that database.
So, okay,
So
I
I'm
asked the
not
wrong
sure if
question.
that-
No, yeah, so you answered the question that I asked, which was in the context of the slide. I guess what I was getting more into why, it's for another talk another time, why are the graph database, native graph databases interesting? What is the particular problem?
Well, graph databases tend to be,
Well, no, I'm
What wouldn't be?
well, okay, yeah.
So many things are represented as graphs, John.
Well, yeah, no,
Traditional
so
databases
I'm
aren't.
asking yes. The words coming out of my mouth are really stupid, okay? But my point is, yeah, we'll take it offline. It's a different, I can't formulate the question I want to ask right now.
Okay, sure.
Yeah, yeah.
Maybe I can address your question a little bit by saying that Tinkerpop or other blueprints is sort of a common data model that can be used across all these graph databases. So anything that you've written for one graph database can be applied to another. Anything you write towards blueprints can be used over all these different graph databases, and they're more than appearing all the time because it's fairly easy to write that mapping.
Right, yeah. Yeah, so your point is you're using the graph model as kind of a ODBC type of compatibility.
Yeah, it's like a
Right.
JDBC for graph databases.
Right, okay. Okay, that makes
And
sense.
what's cool about graph databases in terms of RDF is that they're especially good at traversal-based applications.
Okay.
So things where you want to quickly do a breadth first search or something. The way that the relationships are represented in the database is such that there's constant time complexity of going from one node to the next with respect to how much data is in the database. So you don't have to crawl an index every time you want to get from one resource to the next. And the next resource is a direct link in whatever way that's implemented in the database.
Okay. I've taken up way too much time, and okay, go ahead.
I mean, I don't think the whole thing about what are graph databases and how they interact and graphs as models and things like that is interesting for us to be looking at. You should, some point, sit down with Jesse and show him Tinkerpop. That's not a suggestion, that's an order. Well, because he's very interested in looking at some fast graph stuff, and he's played with a lot of them, and his thesis is on sort of applying rules to graphs, so there may be a real opportunity here for some synergy between.
What is real time? There's a couple of different conceptions of real time that are on the real time web. Data is pushed from producers to consumers. Somebody writes a tweet, and all their followers get that tweet in a short amount of time. It doesn't necessarily mean that things happen quickly.